In our last video, we started to look at the ideas in Chapter 9 when we were focused on the ideas of total costs and fixed costs versus variable costs, marginal costs, average total costs, and average variable costs. And we calculated all those things, discussed what they mean a little bit, and then we graphed the three most important cost curves: marginal cost in red, average total cost in blue, and average variable cost in green here. And we used these cost tables and curves to answer important questions for a firm. Given a market price, how many units should I produce? Am I going to make a profit or not? And should I just shut down and forget it and produce 0 units? And we'll come back to that a little later. But today what we're going to do is we're going to switch gears a little bit, and we're going to focus on looking at a business's actions and decisions from a different angle that is very closely related, and that is the angle of looking at production. So in particular, what we're going to do today is we're going to look at the short-run decisions of a firm, very similar idea to what we did last time, except instead of asking the question, how many units should we produce, we're going to look at it from the angle of how many people should we hire, and what happens as we hire more people, what happens to our output today in the short run. So the first thing let's talk about before we get into this is to talk about this idea of what is the difference between the short run and the long run when an economist is talking about this. The big idea is that when you talk about long-run decision-making, it's not a length of time that's important. So an economist will never say the long run is a month or a week or a year or 10 years. The long run is however long it would take a business to be able to change the amount of any of the inputs. So remember those factors of production or inputs: land, labor, capital, and entrepreneurship. So the long run must be a long enough period of time for a firm to either increase any of those outputs, so get more land, more labor, more capital, which means machines basically, or more entrepreneurship, maybe bring in a partner to help bring together the land and the labor and the capital and help take the risk and to direct the firm. So the long run is a long enough period of time to increase the amounts of those things, decrease the amounts of any or all of those things, and even it has to be a long enough period of time for this firm to exit this industry completely. That means we're going to reduce the level of all of those inputs to 0. The entrepreneur is going to go away. The buildings and the machines and the labor, they're all going to go away, and this firm will no longer exist at all. That's what we mean when we say the long run. The short run is any length of time shorter than that. So what makes something the short run is at least one of those factors of production is fixed, and you cannot change it. That's what makes it the short run. So you don't have full flexibility in all of your factors of production in the short run. Now, to make a simpler example here, let's just think about having 2 inputs. And our 2 inputs we're going to focus on today are capital and labor. Now, what you should be thinking to yourself right now is, why are we spelling capital with a K? I know that capital is spelled with a C, and you are correct. The reason why sometimes, not all the time, but sometimes economists will spell capital with a K is when we want to abbreviate capital. We don't want to abbreviate capital using the letter C because the letter C is most often used for costs. So when we talk about total cost, that's TC. Marginal cost is MC. So if we wanted to abbreviate capital, we're not going to use C. Instead, we use the letter K. Now, one good excuse for this is when you spell capital in German, it is spelled with a K. And a lot of the economists who, in the early days, analyzed these sorts of things were from Germany. So capital and labor. And what we're going to assume, the normal kind of assumption, is that the amount of labor you have is much easier to increase or decrease in a short amount of time, But say the size of your factory or the number of machines or production lines in a factory are probably going to take a longer time for you to increase or decrease. So we normally assume in this kind of simple model that capital is fixed in the short run because it would take longer to bring in more machinery or get rid of some machinery. So in the example we're going to go through today, we're going to assume that we have 8 machines or 8 production lines, something like that in a factory, and we're going to look and see what happens as we increase the amount of workers. What happens to Q, our total product, or in other words, the output, how much of something we're actually making. So total product, when we say total product, all we mean is quantity of output. How much stuff are we producing today in our factory? So to keep things simple, I like to think about the short run as today. This just helps me keep it concrete in my mind. What are we talking about when we say short run? In this kind of example, it's pretty clear to see that for just about any business, I could use more labor today or less labor today. So I could tell my workers to stay home. I could lay them off. But today, I'm still going to have that factory sitting there. I'm still going to have to pay my loan payments. I'm still going to have to pay for any rental contracts on any of this equipment or a lease on the building that I'm in. So this makes a kind of simple way to think about it. Today is the short run. The long run would be, okay, however long it would take me to exit this industry permanently, to get rid of the factory and permanently lay off these workers. So one thing we're going to calculate here is marginal product of labor. And since by now in this class we really understand what the word marginal means, it means change in or additional, right? And we've talked about marginal cost and marginal benefit and all these other things. Marginal product means additional output or change in output. Marginal product of labor is asking how much additional output do I get when I hire one more worker. And the formula for this is always going to be the change in quantity, change in output, divided by the change in labor. It's a slope. So it's the rise over the run in a graph. Let me show you what I mean. So right here we have a graph on our handout of output on the y-axis and number of workers on the x-axis. And so as we go through this production function curve here, the slope between any 2 points, what we're doing is we're going up, we're rising, our output's going up by a certain amount, and then we're going over, we're running by 1 worker in this case. Now that's not always going to be the case. Sometimes we might have a table where we produce more, but we don't have a table where we're increasing the number of workers by 1. So to get that slope, we would want to do rise over run. Say we could go between this point where we have no workers and no output and this point, and we could calculate the marginal product of labor by rise. Looks like we're going from about 0 to almost 20 divided by run, and the run is over 2 here, okay? So rise over run is going to give us the slope between any pair of points. And that's what we call the marginal product of labor in this case. So let's skip these other definitions at the top of our handout here, and let's fill out this table, and then we'll come back to them. Here we have the situation where today we have 8 machines, and we can't change that today. And here we have no workers. And if we have no workers, these machines aren't going to operate themselves. No workers results in 0 output. What's the marginal product of labor for the 0 worker? Now, we've run into this situation many times before, and that's a question that doesn't make sense to ask. So we're going to just put a line through it, or we could put not applicable here. It doesn't make sense to answer the question, what's the additional amount of output for the 0 worker? Now, for the first worker, this does make sense. So when this company hires 1 worker, our output goes from 0 to 5. So that's an additional output of 5. 5 minus 0. So we can say that the marginal product of the first worker is 5 units of output. Change in quantity is 5, change in workers is 1. 5 over 1 is 5. Now what about the second worker? Well, when we hire the second worker, we get 13 units of output additional. So 18 minus 5 is 13. How much additional output do we get for the third worker? What's the marginal product of labor? Well, 36 minus 18, 18. What's the marginal product of the fourth worker? How much additional output do we get? We get 20. 56 minus 36. All right, so let's go quickly fill out the rest of this table here. The marginal product of the fifth worker looks like that's 19. Marginal product of the sixth worker is 15. And then 8, 6, 4, 2. All right, now you tell me, what's the marginal product of the 11th worker? How much extra output do we get? 0. So 0 additional output. How much additional output do we get when we bring in the 12th worker? Well, we don't get any additional output, but the change in the output is -2. That doesn't seem very good. What about the 13th worker? -4. So why do we care? Well, if you're a business, whenever you're trying to make the decision whether to hire another person or not, you have to use this cost-benefit analysis that economists use. And you have to weigh, well, what are the costs of hiring this additional worker versus what are the benefits of hiring this additional worker? Well, the costs are going to be things like recruiting the person and filling out the contracts and how much you have to pay them and maybe the insurance for health insurance and other things you have to do. Maybe you have to train this worker, give them safety equipment, all those additional costs. That's what you'd have to weigh on the cost side. On the benefit side, you have to think, well, if I hire this person, maybe the fourth person, they're going to bring in 20 additional units of output. What can I sell that for, right? So the benefit of hiring someone is how much additional money that person can bring in. So you're weighing the costs versus the benefits. And if they're going to bring in more money than they're going to cost you, hire them, right? So that's basically the decision that you would have to make. So in this case, how many people should we hire? The answer is we don't know yet. We don't have any idea. Now, the reason we don't have any idea is we don't have any data at all yet on how much additional money this person is going to cost us, and we don't know how much this product sells for. We know how much additional units of output these people are going to bring in, but we have no idea how much they sell for. So these people might be making paper clips. And if I'm going to hire somebody and during a whole day they're going to make 20 paper clips, I'm probably not going to hire that person because that's not worth a lot of money. But one thing we can say for sure, we don't know the exact number of people we should hire, but we do know some of these people that we would never hire, would always be a terrible, terrible idea. And we know for sure that we would never want to hire the 13th person, because when we hire them, well, they have to cost us something. And they're actually hurting our output. So that wouldn't make any sense. And same thing with the 12th person. What about the 11th person? Would we ever want to hire that person? Absolutely not. Because when we hire them, it's got to cost us something. And they're not adding anything at all to our output. So that's out. So we don't know exactly how many people to hire, but we know we certainly don't want to go too far and hire 11, 12, or 13 people. Well, let's go on to the next column here and calculate what we call average product, or what a lot of times we call productivity. How productive is your workforce on average? And this formula here is simply quantity of output divided by amount of labor used. So what would the average product be for 0 workers? Well, we'd take the output, 0, divide it by the amount of labor, 0. And what's 0 divided by 0? Yeah, undefined. In other words, don't do it. So again, this is a case where we're going to put a line through this or say not applicable. It doesn't make sense to even ask the question, how productive is our labor, when we don't have any laborers. But for all the others, we can do this. We're just taking Q, 5, divided by L, 1, 5. 18, Q, divided by L, 2. 18 divided by 2 is 9. 36 divided by 3 is 12. And what this is giving us is output per worker on average. And I want to make sure you think about the difference between what marginal product means and what average product means. So marginal product is how much additional output is one additional worker bringing in. So like this 19 here says that this worker, just this fifth worker, brings in an additional 19 units of output. But when we calculate the average, we're averaging over all of our workers. So 56 divided by 4 gives us 14 units per worker on average. 75 divided by 5 gives us 15 units per worker on average. And 90 divided by 6 also gives us 15 units of output per worker on average. So again, this 19, the fifth worker, when we hire that person, brings in another 19 units of output. But on average, when we have 5 workers, we're getting 15 units of output per worker. Okay? Not just for the fifth, but for all 5 on average. All right, so let's fill out the rest of this table here, just dividing the amount of output, Q divided by L, to get the average product. And we get 14, 13, 12, 11, 10, 9, and 8 units of output per worker. Let's think about the relationship between these two columns, marginal product and average product. And to think about this, I want you to think about grades. This is the easiest way to think about this. And this is a very, very important concept that we're going to return to several times when we're looking at business production and business costs. So make sure you pay attention to this and make sure you understand it. Think about the marginal product as additional, right? When you're thinking about your grades, think about marginal as meaning an additional quiz grade, for example, in a class. Average is your average quiz grade in that class. So let's suppose you're starting off in a class, and on your first quiz, you get a 5. What's your average quiz grade in the class? It's 5, right? All right, so now suppose on the next quiz, your additional quiz score is 13. What's that going to do to your average of 5? Is that 13 going to bring up your average or bring down your average? Of course, when you score higher than your average, it brings it up. So this 13 quiz score brings the average up to 9. So your average is 9. Now, on the next quiz, you score an 18. What's that going to do to that 9 average? It's going to bring it up to 12. On the next quiz, you score a 20. Well, that's going to bring up your average again. So anytime you add in a number that's bigger than average, it's going to bring the average up. So your average is a 14, then you get a 19 score, and that brings your average up to 15, and then you score a 15. Well, of course, that's not going to change your average, still 15. But then on the next quiz, you get an 8. That brings down your average. And then you get a 6. That brings down your average, etc. So as long as the additional number is less than average, it brings it down. So this is the relationship that's really important to make sure you understand. When marginal is bigger than average, it brings the average up. When marginal is below average, it brings it down. Now here's a graph of these two so that we can see this relationship. So in blue, we have the marginal, and in orange, we have the average. And we see the average kind of moves up more slowly and down more slowly than the marginal does. But we see here that when the blue is above the orange, it brings the average up. When the marginal is below the orange, it brings the average down. Key idea we're going to see a lot of times. Let's go back and look at some of these definitions up here now. So we talked about the short run versus the long run, and total product and the marginal product of labor is the slope of a total product function or a total product graph. Increasing marginal returns. So what we're talking about here when we're talking about the marginal product of labor is an idea we call marginal returns to labor. What marginal returns means, what this little phrase here is supposed to make us think, is that we are changing one input at a time. We're doing an experiment, and we're increasing one input, just one. It could be land or labor or capital. Here what we're doing is we're adding labor. And so what we're talking about is, what are the marginal returns to labor? What's happening to the additional output? Now, if, as we go down this marginal product column, we see the numbers getting higher and higher and higher, that's what we call increasing marginal returns. So we see increasing marginal returns here as we go between 1 to 2 to 3 to 4 units of labor. Now we don't have a case in this table where we have constant marginal returns, but if we did, what that would mean is there would be at least a part of this table where we're adding more workers and we're always getting the same amount of additional output. So constant marginal returns might be a case where I always hire one more faculty member and they can always teach 3 more classes. I hire another faculty member. Well, they can teach 3 more classes. Another faculty member, 3 more classes. The marginal product is always the same, or at least there's a range where it's the same. One more worker, same number of additional units of output as the previous person. So increasing marginal returns, each additional person is more and more and more productive. Constant marginal returns, each additional person is just as productive as the previous one was. Diminishing marginal returns, of course, is then going to mean, is there a case where as we hire more people, the additional output is diminishing or decreasing or going down? And we see that in the table here as we go from 5 to 6 to 7 to 8 to 9 to 10 and even 11, I would call it that, decreasing or diminishing marginal returns. And then the last possibility is we could possibly have a case where we could have negative marginal returns. That just means that you hire another worker and the actual output of your factory decreases because you hired that person. Maybe we just don't have enough room in our factory for all these people we're trying to pack in there, and people are bumping into each other and producing less. So these last 2 cases here, the 12th and the 13th people, we actually have negative additional output or negative marginal returns to labor. So this discussion of marginal returns brings up an important law in economics. And again, a law just means it's something that appears so regularly that we can consider this to be the truth. It always has to happen, at least at some point. So this law of diminishing marginal returns here says that in the short run, as we increase the amount of one input, so again, marginal returns, write this down. Anytime you see the word marginal returns, we're just increasing one input at a time. So the law of diminishing marginal returns says as we add more and more and more of just one input, imagine we have a factory and we keep adding workers, but we're not giving these workers more equipment. We're not giving them more space. We're not increasing any of the other inputs, just adding more and more and more workers. That sure, output could keep going up, but it has to start going up at a slower and slower and slower rate at some point. Now, why might this make sense? Well, let me give you 2 ways to think about this. Suppose in our business we have 10 computers. We might imagine that for the first 10 people we hire, each person gets their own computer. So we might have constant marginal returns. Or maybe because these people are able to work together and help each other and give each other hints, maybe we could even have increasing marginal returns as we hire those first 10 people. But what about the 11th person, and the 12th, and the 20th, and the 50th? Well, since we're not giving these additional people more equipment to work with, these people are going to have to share the computers, and this has to lead to not necessarily decreasing output, but the amount of output can't keep going up at the same rate forever. It has to start slowing down. It can keep going up, but at a slower and slower and slower rate. So this is the idea of the law of diminishing returns. Now another example, this is the one that my professors used to always tell me, is let's imagine a farm. It's a very small farm. Let's suppose this farm is just a bucket of dirt. So we're restricting our land. We just have one bucket of dirt. And let's think about the other inputs we would need to grow food. Seeds, water, sunlight, fertilizer. So we have a given amount of seeds, a given amount of fertilizer, a given amount of water, and a given amount of sunshine. And we're going to increase one input, labor. So we hire one person to farm the bucket. 2, 3, 10, 100, 1,000,000. Does it make sense that as we keep using more and more and more people, but we're not using more dirt, we're not using more sunshine or water or seeds, that maybe the 100th person could grow a little more food, but it has to be a little bit less than the 99th person, or the second person, or the first person gave us. There has to be a limit, in other words, of how much food you can grow out of a bucket. Now, this doesn't mean there's a limit to how much food you can grow if you allow us to increase all of our inputs. More land and more labor and more sun and fertilizer and seeds and all that, then there doesn't necessarily have to be a limit. And we'll talk about that a little later. So the law of diminishing marginal returns just says that at some point, the additional amount of output you get as you increase the number of just one of the inputs at a time, in this case labor, the amount of additional output has to go down a little bit less than the one before at some point. That doesn't mean that we can't have some regions where we have increasing marginal returns, but just at some point it has to start leveling off. Okay, last couple of columns let's do here. Let's tie what we're talking about here to costs. So let's put some prices on these factors of production. Let's suppose that the price of capital is $10 per machine. Maybe we're renting these machines here. And let's suppose that the price of labor is $20 per day. Let's calculate the total cost of each of these scenarios. So what if we had no people, but we have 8 machines, right? We can't get rid of those 8 machines. How much would our total costs be? Well, it'd be $10 times the 8 machines, $10 each. 80 plus, well, 0 for the labor because we don't have any laborers. So our total costs would merely be the price of the machines, $10 times 8. So it'd be $80. That would be our total costs. Since all the money we're spending here is on the fixed factors of production, those machines that we can't change today in the short run, we would call this $80 the fixed costs. We're not spending any money on variable costs. So when we're producing 0 units, total costs are only for fixed costs. Now, what about if we hire this first person? Well, then we're going to be spending $80 for the 8 machines plus $20 for the one person, and our total cost would be $100. What's going to happen in this table is that as we go down, we're always hiring one more person, and so it's always going to cost us $20 more. So let's fill out the rest of this table. $120, $140, $160, $180, etc. So now we have a total cost table. Now, let's talk about our marginal costs for this business. So here we're asking, what is the additional cost of each additional unit? Now, in our last lecture, we had a table where the table was giving us costs by number of units. 0 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Here, our table is different. Our table isn't giving us a list of how much it costs for each individual unit. What we're going to have to do is figure out the marginal cost in a similar way to what we were talking about over here, that the marginal product is change in quantity over change in labor. It's a slope. Marginal cost is also a slope. It's change in total cost divided by the change in output. That gives us an idea of how much each individual unit is costing as we produce it. So for example, as always, when we're talking about 0 units, we're not going to be talking about marginal cost. It doesn't make sense to even discuss that, right? So this is a not applicable again. But when we go from hiring 0 people to 1, and we're producing 5 more units of output, this marginal cost is going to be the change in total cost. Well, change in total cost is $20 divided by how much additional output did we get? 5. So $20 divided by 5 gives us an additional cost of $4 each. So let's talk about, again, why we just did what we did. Marginal cost is supposed to tell us the additional cost of each additional unit. Since we're talking about producing 5 more units here, we don't really know what the first unit or the second unit costs. What we have to do is kind of say, well, in this range, when we hire this first person and we get 5 more units, since that costs us $20 more and we get 5 more units, each of those additional units must be costing us about $4 each. All right, let's do this again. When we hire the second person, we get 13 more units. So it costs us $20 more, going from 100 to 120. We get 13 more units. That's our marginal product. And so $20 divided by 13 units. What do you get when you do that on your calculator? Get about $1.54 each. $1.54 each as the marginal cost in this range of units as we're producing between 5 and 18. Okay? Take a minute and pause the video and you calculate and fill out the rest of this table. I'll do the same and then we'll compare notes. All right, well, here's what the rest of my column looks like. Again, we're just taking the additional $20 it costs us to hire each of these additional people. That's the change in the total costs, divided by how much additional output are we getting. And that's that marginal product of labor. So we're just taking 20 divided by 18, 20 divided by 20, 20 divided by 19, 20 divided by 15, etc. Until we get down here to the 11th and 12th and 13th worker, we can't take 20 divided by 0. That just doesn't make any sense. It also doesn't make sense to talk about the marginal cost of these -2 units. What's the additional cost of losing 2 units? That's not really the marginal cost of an additional unit, right? So make sure you understand why we have these not applicables down here at the end. It doesn't make sense to ask what's the additional cost of producing an additional unit when you're not producing additional units anymore. Okay, well, the last thing let's do to tie back into what we were doing last time, let's calculate the average total cost. Remember, average total cost just tells us the cost per unit, the average cost of all the units we've produced. And that's simply total cost divided by quantity. Now again, we can't divide by 0, so when we take the total cost of 80, and if we want to divide that by 0 quantity, just don't do it, right? So again, put a line through it or say not applicable, whichever way you like. But here we have a total cost of 100. We're producing 5 units. That means the average cost per unit is 100 divided by 5, or $20 per unit total cost. So again, make sure you understand the difference between what we're saying here is marginal cost. This is an additional cost of $4 each to produce these first 5 units. Here we're saying when we take all the costs, including the cost of the machinery into account, not just the $20 in the labor costs, we have $20 per unit, and that's the amount we're going to need to pay all of our bills, to pay the entire cost of the firm, which is $100 when we're producing 5 units. And here we have $120 divided by 13 units. So $120 divided by 13 units gives us about $6.67 if we round that to the nearest penny. $140 divided by 18 units gives us about $3.89 per unit. All right, now it's your turn to pause the video. Do it, please. Pause the video now and fill out the rest of this table. Make sure you really understand this by doing it, and then I'll show you my answers. So here are the rest of our answers. Just taking, again, that total cost and dividing it by the quantity column to get the average total cost, or the average cost per unit as we increase our production. And as we normally see, our average total cost starts high, decreases down to a minimum here of around $222, and then starts increasing back up. So the last thing I want to do today is just look at a graph of these costs that we just calculated here. The marginal cost in the blue, the average total cost going down, reaching that minimum and going back up, and then the average variable cost, which we didn't calculate in the table. But average variable cost would just be breaking out the variable costs from the $80 we have in fixed costs here and calculating the variable costs per unit. We see similar looking graph to what we saw last time. Now in the next video, we're going to go through some more definitions from this chapter and make sure we understand things like accounting costs versus economic costs and economic profit versus accounting profit. I look forward to seeing you in that next video. And as always, this is Dr. Berkey signing out. Talk to you next time.